we are at the foundational questions time again, and I'm here with Antonio Guerre, who is the founder of Foundational Questions Institute. So we need to take advantage of that. So hello, good morning.
Good morning.
And first question, and you founded the institute in I think 2006 with Max Tegmark.
That's right.
Tell us about it. Why did you do that? And what's the whole inspiration, the process, everything, the reason?
Yeah, so at the time, Max and I were both young faculty. We were theoretical cosmologists primarily. But even more than some of our colleagues, especially the ones in our universities, we like to think about the really big questions, like not just the universe, but the multiverse, and not just early universe cosmology, but really, really, really early universe cosmology, and not just quantum mechanics, but the foundations of quantum mechanics and things like that. And these were topics that you would at most get sort of tolerance from for your colleagues as long as you wrote enough kind of more conventional papers as well. Max in early years had a rule for himself that he would allow himself one crazy paper, as he called it, for every 10 more conventional, papers that all would get at the citations that his colleagues wanted, and had all the numbers and the data in it. And so we were both sort of in this situation, and feeling like it was a shame that there were so many barriers to people who wanted to address the really big questions that got them into physics in the first place. Often, people think, oh, they read books by Stephen Hawking, and they read books about the multiverse and black holes, and then they get into the field and find that there's this huge pressure to work on much more applied things or much more incremental things, and that the things that got them into physics in the first place are often actually frowned upon, and like, oh, that's like that weird black hole stuff. Black holes are much more acceptable now than they used to be, and quantum foundations are as well. But there was an opportunity that we had from a very forward-thinking foundation, the John Templeton Foundation, which was just getting into supporting physical sciences. And they said, we'd like to put some money into these really big questions of the kinds that you guys like to think about. What should we do with it? And so Max and I tried to dream up, like, if there was an organization that could support people like us, and we knew there were others. Didn't end up supporting us particularly, but we hoped that it would support other people that were like us. What would that look like? And we decided that, well, you would want a community. You'd want these people to be able to find each other and really talk with each other and meet up and sort of give each other moral and other sorts of support. You'd want funding support that would allow them to have more time and space and resources to do the sort of research that they wanted. You would want convenings to actually get them together. And you'd want other weird things that we might dream up. And so we built the Foundational Questions Institute to be that organization, to try to, like, whatever the barriers were to these sorts of researchers thinking about foundational questions, being able to do that research that they wanted to do, try to take away those barriers. If they're sociological, if they're financial, if they're organizational, whatever they are, try to lower those barriers so that they could really approach the questions they wanted to approach. And that was now almost 20 years ago, going strong. And we've got some Foundational Questions Institute members here of the several hundred that we have grown to. And it's just been enormous honor and so much fun to interact with this community that we've built.
Okay, so there are so many things there. I mean, also including if you see a problem, you just basically just go and take care of it and lead by example. So many of them, I know you didn't really intend to exactly say those things either, but I am going to pick a few of them. But why didn't you call it Fundamental Questions Institute? And just in case there's
that's a good question. Because I think in public parlance, fundamental and foundational often sound fairly similar. In physics, they're kind of different things. I would first say there's pure research as opposed to applied research. Like I think there's a lot of support for applied research in the physical sciences. There's less for pure research, and I think it's worth making a case that pure research is really, really important. All of the applied comes from the pure originally, and there's a temptation in funding things and in labs and grants and so on to look for the thing that's going to give you the thing that you want immediately. You want the technology, so let's fund the applied research that goes right into the technology. But you can't just start at the applied research without the pure research to back it up. And I think forward-thinking governments have seen this for a long time, and I think it's worth keeping in mind that pure is important. But this goes a little bit beyond that. In fundamental physics, that means a fairly particular thing, which is like, I think a lot about fundamental particle physics, the idea that most of the big things are made up of particular types of little things, like elementary particles. There's an idea that we can study the sort of fundamental forces of nature. There's just a few of them. There's 4. Depending on your energy scale, there's 3 or 2 or 1 maybe. But that's different from, so fundamental particle physics talks about the standard model of particle physics and variations on it and so on. That's a little bit different from foundational. And when Max and I were thinking about this originally, we thought of foundational questions as those that are kind of have to do with the deep or ultimate nature of reality, like that are at the foundations of things, but not necessarily in that they're the smallest things or they're the most elementary things in physics, but they're the ways that you have to think in order to build the rest of the structure, and the ways that you kind of take something and pick it apart and go deeper. Like you keep asking, well, why is that? Like a little kid, why do you do that? Why do you do that? Why do you do that? So the foundational questions that we started to think about were, what's the fundamental nature of, energy and matter and information and mind, and how do those things relate? What is the very large scale structure of the universe or the multiverse? What is quantum mechanics really telling us? We understand the math, we don't understand what it means, and that's still true. It's been true for as long as quantum mechanics has been around. So questions like that are it's, you get a feel for them when you're in the field and what the difference between those and like just fundamental physics are. But we really wanted to target that second one.
It's actually interesting because I was thinking of it as almost a spectrum first when you first started thinking about it. Then it's maybe not even a spectrum because it's not on the same frame even. It's maybe a different completely different way of thinking by nature.
I think it's fairly different. I mean, we do still get a lot of proposals, for example, from fundamental particle physicists who say like, yeah, but these are the fundamental constituents of nature. Why isn't that foundational questions? And so it's not always so clear cut, but you sort of know it when you see it.
I mean, it's very interesting, actually. I actually thought that I knew the answer. Okay, thank you for that. And then question, we are talking about foundational questions now. So I'm again reminding everybody, there will be time about like ask me anything type of foundational questions to Anthony, and we're going to get there. So prepare your foundational questions. And again, I will remind you, there are a number of FQXI members here. If Anthony cannot answer, yeah, over there, I'm seeing them. And they can help, Anthony. Okay, so what are your foundational questions? What kind of things that you are working on to inspire everyone's questions, perhaps?
Yeah, I've spent a lot of time thinking about time and the different ways that it manifests. I talked a little bit about this a couple of days ago. I think one point that I hit in that is the relation between different ways that we describe reality. There's a way that we describe reality in terms of fundamental particles and forces and fields, and there's a sense among physicists often, especially, that, being physicists, that this is the more real description of reality. That this is, those other ones are just sort of derivative, and in principle they all follow from the one that I came up with as a fundamental particle physicist. And I've started over the years to question this more and more. There are different ways that we engage with reality, and what is the relation between those different ways? We talk about, I talked about time, but it can, when you talk about free will or consciousness, there's a level at which you're addressing those questions. There's a sort of language for reality in which you're posing those questions, and reality, will engage with you at that level in that language. And there's another level of the, fundamental particles and, determinative physical laws, but and those two have to coexist with each other. Like nature is consistent in the sense that you will be able to find that there's a way to tell those stories at the same time. But I have more and more questioned the idea that one of them is the story, the right story, the more real story, and that the other ones are just derivative from it. Rather, I think as the more you go into those relations, you start to feel like what reality is what it is, and we can engage it in these different ways, but it doesn't have to like obey our desire to have like the one right true story about it. So I spent a lot of time thinking about that. I spent a lot of time thinking about the universe versus the multiverse. One of my favorite sets of projects that I've worked on over the years is the idea that we could actually look for other universes as they appear in astrophysical data. This seems like something that just like is preposterous, right? The whole idea of the multiverse originally felt like, well, yeah, these are things that you theorize, but there's no way to get to them. There's no way to know. It's just like metaphysics or pure speculation. But it turned out that if you thought and like really did the rigorous work, you could find that there actually were versions of the multiverse that would leave an impact on our universe, and you could go and look for. And we went and looked. Didn't find the other universes. Well, we found some things that looked like other universes, but turned out they were probably noise. But it's the fact that you can go and look and say, here's the limit on how many other universes ran into ours, is a pretty fun thing.
Tell me a bit more about that. What's the joy of finding it, finding out or not finding out? Like, how do you feel?
Yeah, I mean, the thing that separates science from pure speculation is that you want to have answers, and the great part about answers usually is that they aren't really answers; they're just provisional, and they lead you to more interesting questions. And I took this, I've always felt like the questions are the really interesting and fun part. Like an answer is, momentarily satisfying in physics, but really as soon, almost everyone I know, the people who really are exciting thinkers, as soon as they get an answer, it immediately just leads them to the next series of deeper questions. And I think this so much that I wrote a whole book called Cosmological Koans, which is essentially focused on just asking lots of questions. And it gives answers, but only in the service of asking those more and deeper questions.
Okay, so there are two things there. I think that connects the whole topic to society. You talked about reality, for example. I am thinking that many people many of us actually are looking for what's real, what's not. So this topic also is, so that's connected to the reality. And the other one is the joy of asking questions and digging deeper and so forth. What's the connection with society and foundational questions then? Can you?
Yeah, I think these, everybody in their individual life, I think, thinks about from time to time the big questions of their life. Why am I here? What was I born for? What happens next? What's it all about? What should I be like? Do I have a goal? What's my purpose? All of these questions as an individual. And I think we ask them, as a society and as a species, and have since the beginning of our existence. We've asked those big questions. And I think the thing that is exciting about the last few hundred years is that we've discovered methods to ask those questions better. We don't just ask, what is the world all about and what is it made of? Is it earth, air, water, and fire, or something else? And let's just argue about it without... we now have a way to do experiments. We now have a way to mathematize those theories. And we have a way to actually make progress in that we gain control over the material world in a dramatic way, but also get to ask those questions in a more and more deep way. And I think that feeds back on society. We've seen in like the very obvious cases with like Galileo and Newton and Einstein, they're huge figures in our cultural evolution, and they've influenced our worldview in tremendous ways. But although those sorts of like singular figures aren't as common now, science has sort of transformed a bit so that it isn't so hero-driven. Still, the effect of those big questions and foundational thinking permeates the way that society, imagines itself and imagines the world and sort of conceptualizes things. So I think it's very much still there.
And if you iterate that, that will be a connection to the culture then. Am I right?
Certainly. Yeah. Certainly. I think the way the same way that we imagine the world plays out in the way that we behave in the world and the way we conceive of ourselves. And that has happened historically a lot through religion, but it also has happened in modern times through science, because they're both addressing these very large questions. And those, the way you understand how the world works, how it originated, what purpose it has, what purpose people in it have. All that affects the way that you make choices and lead your life.
And perhaps we put the culture topic in a different context, and it's going to be my last question before I open up. So, why do we need, like, in the context of technology and innovation, everything going forward the way that it is, and faster, maybe in accelerated space, why do we need foundational questions, and why do we need to make it part of the culture even, perhaps?
Yeah, and well, I'd say a few things to that. One is that people are interested. People read the magazines, watch the shows about these big questions. You all are here as a testament to that. And I think we should match. One of the frustrations that led to the creation of the Foundational Questions Institute was the disparity between the interest that people have and the actual resources that society puts towards these questions. Raise your hand now, this is going to be a little biased, but raise your hand if you think about the big questions of life for more than 30 seconds every year. What it's all about, like what the world is doing, like what reality is. So 30 seconds isn't very much, that's about a millionth of your time. If you think about how much our society spends on really supporting foundational questions research of the type that I've been talking about, it's maybe $100 million a year or something out of a $100 trillion economy. So this is one millionth of our societal resources that we spend on the really big, deep, important questions in my mind. This seems like a dramatic mismatch. Like, these are so big and so influential and permeate so much of our society, we should be spending more. But I think there's also a more sort of practical sense where, going further than when I talked about pure research versus applied, the foundational questions sort of lay the groundwork for things at other levels that do end up becoming important technologies. So a really key example, I think, is quantum mechanics. Quantum mechanics was first worked out in the 20s and 30s. Then there were the 40s and 50s and 60s and 70s and a bit of the 80s where you weren't really allowed to talk about what quantum mechanics meant. What were the deep questions that they talked about in the 20s and 30s when they were developing it. Then for like 50 years, you weren't allowed to talk about those deep questions anymore. You just had to shut up and calculate and grind the math. And because no one was allowed to talk about those questions sociologically, like that was the sociology of science. There wasn't funding. There wasn't respect for it. There were so many things, all of quantum information theory, all of quantum computation, the quantum resources, all of the sort of interesting topics that anything starts with quantum at this conference is talking about, all of those could have been worked out decades earlier, but you weren't allowed to do the foundational work that it took to really understand quantum mechanics and grapple with those in the way that it took to start to build those technologies. So it was like a gigantic delay. I think things are similarly happening elsewhere where we're either delaying technologies or getting technologies without the foundational understanding to deal with them. So I think AI is very much one of those right now. There are questions like, what does it mean to have intelligence, be an intelligent thing, have agency, consciousness? What do intelligence and agency and consciousness have to do with each other? Can you have intelligence without consciousness, or consciousness without intelligence, or agency without consciousness? So we ran some programs in this with FQXI, and I'm quite proud that we did that. But they were small, honestly, and they did not really plumb the depths of any of those questions. Now we have AI, and we've got no idea how it works or what intelligence really means. And what agency really means. We're going to have machines that are telling us they're conscious, and we will have no idea whether that is true or not. That's going to be a big deal, and I think we are very much behind the curve in where we need to be in our foundational understanding of these sorts of concepts, and we suddenly have the technology without really understanding it. So I think we're very ill prepared in that sense. Again, trillions of dollars developing AI capability, maybe tens or hundreds of millions of dollars developing the capacity to make that AI do what we want it to do and have things go well. Basically nothing understanding the real foundational questions about what AI means and how we should think of it from this very deep perspective.
Okay, so that's a really good call to action and something to really think about and do something about. So, what about the questions? Now
let's get some
I'm gonna
questions.
look at the audience. Okay, I'm gonna go this way first. Sorry, sorry. Can we start here? Yeah, thanks.
Hi, my name is Doha. I'm an innovator in TKS. I'm passionate about neuroscience and AI. I want to ask, what do you think is an effective way to discover and ignite your foundational purpose? Like, how can one draw inspiration to identify their driving inspiration?
I think you're in an even better position than most of us here because it's being like a kid, like asking those questions again and again. Why is that? And it can be at first embarrassing to say like, well, I don't understand that. Why is that true? But most of my days, like after being a physics professor for 20 years, is spent, well, I don't understand that. Why is that? Like, this doesn't make any sense. Like, that's where things get interesting. And at first, when you start asking those questions, a lot of the things that you will ask will have answers that other people will know. But as you go on and train yourself in really asking better and better questions, you'll start to come to more and more questions that it's harder to find the answer to, and people don't really know. And they might pretend that they know, but if you ask more questions, you'll realize they don't actually know. And then you'll start, as time goes on, to get to the questions where nobody knows, and that's where it starts to get really exciting. So I would just say question, 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 and go to the things that you find most interesting and exciting and juicy, and don't really accept that the answers that you find are fully true and fully worked out and fully understood. Again, sometimes you'll be wrong, and they actually are, but if you keep asking those questions and keep that, I think, innocence and sort of keep the kid in you alive to keep asking those questions, you'll start to get more and more fun out of it.
Beginner's mind, it sounds like.
Beginner's mind.
Yeah.
Thank you.
And let's go zigzag a bit. How about the first row first? Yes, then I will go back and forth. Yeah.
Anthony, you are director of Future of Life Institute. My question is, can we program a future?
Can we program our future? I hope not. I think what is exciting about the future is that it is up to us. You know, we have agency over our future, both individually and as a species, as humanity. I think we're right now what we're doing is not really choosing our future. We're not really thinking like an individual that is planning out, here's what I would like the future to look like, let me work toward that future. We're not really planning it. What we're doing right now is we're sort of following the local incentives of let's build new technologies, let's build new products, let's make money as individual companies, let's invest in companies that make more money. All of those things are great, and they build wealth, and they build the economy that we have now, and they build new understanding of things. What they don't necessarily build is the future we want. And so I think we should spend a lot more time with my Future of Life hat on, thinking about what are the fundamental things that we want in the future. What are the things that aren't working? What are the problems that we want to solve? How do we envision a world that we really think is an exciting one to be living in? And then let's spend at least some of our effort steering in that direction rather than just like hitting the gas in the car, hands off the steering wheel, brakes don't exist. That's what we're doing with AI at the moment. But let's get our hands on the steering wheel a little and make some choices about where we want to go. And I'm not sure what exactly you mean by programming the future. If you mean that, then I'm all for it. If you mean just following a set of rules, then I think I'd rather be a little bit more creative and free.
So we go this way, maybe second row. Yeah, yeah.
Hi, my name is Angela Majumdar, and I'm a student researcher in astrophysics. And I really liked how you talked about free will and why things are the way they are. So I just wanted your perspective a little bit on, do you think the universe is fundamentally like mathematical, or is it math just something that humans created to interpret the universe? Like, a simpler question would be, do you think math is invented or discovered?
Yeah, this is another one of my favorite foundational questions, so thank you for that. I think, as with many things, it is neither and both. I think in math, so there's a long answer to this I could give, but let me see if I can give the shortest, a short one. I think it is both the case that mathematics and physical laws are free inventions of the human mind, as Einstein put it, but they also are weirdly and unnaturally effective, as Eugene Wigner put it, and both are true. And the thing that we do with physics is create this continual dialogue between our minds and mathematics and the physical universe, and that dialogue has grown deeper and richer in time, and it has turned out that mathematics and sort of abstract physical laws have been just amazingly, amazingly good at explaining a lot of natural phenomena, but amazingly bad at explaining a lot of other ones. Like when you go into biological systems or very complex systems, the sort of nice, simple mathematics that you use to do fundamental particle physics just utterly fails you. It just does not work, and you need a whole different set of apparatus to do that. Probably the same thing for intelligence and mind. So I think we should accept that there are key ways of describing physical reality and approaches to it where mathematics is exactly the right tool, and is clearly has some structural affinity with the reality that we're engaged with, but that's only part of reality and only one language for engaging with it.
Oh, thank you. Second row, perhaps there. Yes.
Thank you. My question is, would you say that obtaining a better understanding of our consciousness could bring us closer to a better understanding of the universe?
Certainly. I mean, the universe that we all experience is in our consciousness. And I think the universe that we actually experience is created by our mind, right? That's where we all are. The thing that you're looking at is not the thing that you're looking at. It is the simulation that you're running in your mind of a set of sensory data that is coming in, and you're creating this whole model of reality, which is the thing that you're experiencing. So everything is mediated by our mind, everything is experienced in our consciousness. And I think there's a tendency to say, well, yeah, we're experiencing this thing in our mind and like recreating it in our mind, but there's the real thing out there that we're approximating and we're trying to get close to. But what is that real thing out there? I don't think it's so real and out there as we really assume that it is. There is some level of, there are things that are more objective and they're more agreed upon between many different minds and sort of feel like they don't have to do with your subjective feeling or experience. And there are things that are obviously everything to do with your subjective experience. You dream some dream that is entirely yours. But there's a huge amount in between. And there's not so much, I think, subjective and objective things, but a sliding scale between subjective and sort of personal, and more objective when you get to things like, you know, the formula for expressing pi and sort of the Pythagorean theorem that feel very, very objective. But there's a lot of rich area in between. And I think as we understand more about our mind and our consciousness, we're going to understand more about how all of those things in between are constructed, which is really most of what we experience in the world.
Thank you. And this, thank you.
Well, hi, my name is Warifa, and I'm a TK student, deeply interested about quantum mechanics and quantum computing, plus a bit interested about BCIs. Well, I actually have 4 questions, but just choose one of them from 1 to 4, because I don't want to waste time.
Okay. He had to answer all 4 of them, but I get to choose, because he did all the hard work yesterday.
Yeah.
Great. Let's hear.
Go for it.
Questions.
Go for it.
You want 1, 2, 3, 4?
Oh, I just choose one. I'll take number 3.
I love that.
Okay, so this is a bit interesting. Why we can't see how quantum works?
Why we can't see how quantum works? Well, I could take that in a few senses. Like, obviously, we can't see how quantum works because we're just too big. You know, the quantum doesn't have to be small things technically, but the way we experience the quantum is all having to do with, you know, individual particles and we certainly can't see those individually. There are ways that we can make quantum mechanics more manifest as we do experiments like the interference experiments, that you can see that things are behaving weirdly, as opposed to what you would expect naively. But there's also, why can't we see how quantum mechanics works why can't we get it? Like, why is it so weird? And I think that is just a fundamental lesson that our minds were adapted to deal with the physical reality that we've evolved and sort of grown up with. And that is not necessarily the way nature, intrinsically is. And when we ask questions very carefully of nature, we have to accept that nature isn't necessarily going to answer them in the terms that we want nature to answer them in. And it's the classic, is light a particle or wave? We have trouble imagining that something can be both one way and also a totally different way that feels contradictory to us. But we see that when we work out the mathematics and when we really analyze this in detail, that it can. Like, every well-defined question that we ask of a particle about its particly nature, it gives us a well-defined answer. And if we ask a particle, where are you? It'll tell you, I'm a particle that's right here. If you ask it, okay, what's your wavelength? It'll tell you, yes, I'm a wave with this wavelength. And that's fine. Like, it doesn't have to accord with our intuition if it doesn't want to. We have to adapt our intuition to accord with how reality is. And I think that's exciting. Like, if reality was just the way we think it is, naively, as like on an everyday level, if everything was just the way it looks, what a boring world.
We have to wrap up, but can you wrap up with a very quick question on quantum biology then, as we went a little bit that way?
Yeah, I think one of the there are intersections between fields that I think are often neglected, and there's lots of juicy stuff, and often it doesn't get addressed because one of those barriers that I talked about at the very beginning is field boundaries. Like, if you're a biologist, quantum mechanics is not something you know or think about. If you're a quantum physicist, biology is that complicated thing that those other people do, and it's exciting and interesting to think about where those meet and what the fertile ground in between is, and it takes particular types of researchers to be able to do that. So I'm enthused about quantum biology as one of those fertile realms that just hasn't been explored nearly enough, and that there might be really, really interesting work to be done, and new, appreciation for how quantum particular events are happening in biology, and new perspectives on biological systems, but also more new perspectives on what quantum mechanics really means, like the difference between being able to predict something or not predict something, and biological systems are some of the most unpredictable things. And I think I could go on with lots of fun, interesting questions at that intersection, but I agree that is a place that I would single out as particularly juicy and interesting right now.
Yeah, I think this is a good plug-in, and thank you so much for all the questions. You know where to find us. Thanks.
One more thing. Feel free to grab me after this. I'll be around if you've got more questions.